get the cherry on the cake. I don't know if it means anything in English. Yeah, cherry on the cake. So Gilles will be the cherry on the cake. So Gilles is a climatologist from LSCE, which is the lab at Saclay, and he's a paleoclimatologist, and he will now explain how he thinks he can be useful to the future of mankind.
Thank you. Okay, so thank you everybody to come by night. Jacques told me that at the beginning he wanted to show a film called The Big Energy Crash, but finally he couldn't get it, so he invited me. So thank you very much. Okay, so in fact, as he said, I'm a model of climate, and I discussed during more than 1 year with Jacques, Hervé, Jean-Marc, Jean Covici, and many peoples. And they offer me tonight in about half an hour to explain you what I think about the fact that all the climatologists, in fact, during these last, let's say, 30 years, they organize themselves to produce this well-known IPCC report each 5 years. And from that experience, I thought we can do something on energies. This is what I will try to explain you. So the next slide is about the outline of what is in my brain, and it will not take, I think, more than half an hour, and then we could have a discussion. So the first step is to think about what is the added value of being organized at an IPCC. This has some drawbacks, but also some good things. And I will show you that this provides a good basis to make some research on the impact, and also that this research on climate change impact has been shown as quite important to communicate, of course, with. And due to all this, which are the three first parts, I thought that a very big issue was energy. And I will come to that during the second part of my talk, and I will try to make some analogy between the way we know, we think, and scientifically we get a framework from climate and what we can do for energy. So the first slide is a slide, you will get the same for energy, is about where we are concerning the present day climate. So this is just a picture that you can find in the report, the fifth report. And you can see here only, it's just a matter of fact, what is measured in terms of temperature, sea level rise, and CO2 for this period. So this is some recent data. Myself, I work on, as Jacques said, on paleoclimate. So, but this evening I will not spoke about paleoclimate mainly. I will talk about future climate and present day climate. So from that, next slide, we show that we want to make some projection. So to do that, we get a hierarchy of model, but this evening I will mostly talk about the general climate model, which are the most sophisticated model of Earth's system. I don't like this expression because it is not really an Earth system. It's just a kind of two fluids, dynamics, atmosphere, ocean, a little bit of vegetation, sometimes cryosphere when we take into account long-term differences. So we get this big model. There are some 20 models like this in the world. In France, we get mostly two, one in Toulouse and the other at IPSL, where I work. And from that, you make some projection. So the next slides show you the projection that we get. And here, what you can see here is the changes that are projected for the next century concerning mainly the temperature and sea level rise. And what you see here is a difference that you get depending on the scenario that you use. So a very important issue here is the fact that on narrative basis, there are scenarios, and the most sophisticated computation machine works on this scenario. So we can criticize this scenario. For instance, I know that Jacques is not very glad of the RCP 8.5, but there are different scenarios, and on these scenarios, a lot of science is bring. So I will not go into details, but there is one scenario which could be called as RCP 2.6. This is a scenario we control what is going on, and after mid of the century, we are able to make the CO2 constant, and then to decrease the concentration of CO2. And the RCP 8.5, to say it very briefly, it's business as usual. We don't do anything and we look what happened. And so here you see the difference in terms of sea level rise and of temperatures. And what you see is something that everybody knows, I think, in this room, is that depending on the scenario of CO2, the CO2 pathway that you use, you will be beneath 2 degrees Celsius if you use RCP 2.6, or you will be between 4 or more degrees Celsius at the end of the century. And it's the same for the sea level rise. If you control, you can keep under 40 centimeters, but if you don't control, you can go beyond above 1 meter. So the next slides, the next slides show you in terms of anomaly at the end of the century compared to the first decade of the century, temperature for the upper panel and the precipitation for the bottom panel, both in terms of anomaly, and this is for the weak scenario on the left or the strongest scenario on the right. Okay, what you can see with your eye on these scenarios is that, of course, depending of the scenario, the amplitude of the warming is different. If you are if you take more caution, you can see that there is a change between continent and ocean. Of course, the continent warms more. Why? Because the ocean, they can evaporate water, so this is just physics. The continent warm more, and what you can see also is that the high latitude is warmer than the equatorial area, and this is mostly due to the albedo effect of the snow. So, okay, all this is something that you can see very easily, and you can see also that the response in terms of precipitation is very different. I mean, it's not always in the same direction. There are areas that will be drier and areas that will be wetter, of course, because of Clausius-Clapeyron. In a warmer world, you are also in a wetter world, but you really need general circulation models to compute this precipitation, which is really different from an area to the other one. So these are a kind of basis, I would say a very strong basis, and these strong bases enable a lot of discussion with policymakers, but also a lot of discussion with citizens and scientific about what does it mean, the climate change. So this, for me, is quite important because it is a basis for research. So, okay, now that we get this basis, we can go a step further, and I will show you one study that explore from that where we can go if we explore other pathways. So the next slide is just a discussion to say that the climate system is very complex, and in fact with our model most of the time we capture only what we put inside the model. That means what we think will be the future, but this is mostly forced by the CO2 pathway we use. But there are reasons to think that the Earth climate model doesn't react always like that, and that there is threshold in this system. So there are thresholds that are linked with carbon and climate, that you know, for instance, when you emitted 2 CO2 molecules in the air, one will be stored, but the other will disappear due to the continental biosphere or to the marine biosphere. And this ratio is not fixed forever. It can change, of course, depending of the warming, for instance. Another thing is that you can have feedback that are positive. For instance, here concerning climate and carbon, you can melt the permafrost, and this will be taken into account in the next report with more caution. And you can also maybe destabilize the clatrat, but this is another story. I will not come into this. But there is also a threshold that concerns the cryosphere and the climate. If you melt the ice sheets, you will bring a lot of fresh water in region where there is formation of deep water, and then you can decrease drastically the transport of energy. So here I will show you one example concerning the cryosphere and the climate, and show you how this can impact many aspects of the world and the climate of the world. So the next slide is just to tell you that what happened from the past, and this is the only time I will really discuss about that, what happens when you melt an ice sheet. So from the past, we perfectly know how the last deglaciation occurred. As you know, 21,000 of years before present, there were not 2 ice sheets, but 4 ice sheets, with a big ice sheet called the Laurentide over the Canada and North America, and another one called the Fennoscandian over North Europe. And these two ice sheets that has disappeared, that disappeared in 10 kiloyears, from 20 to 10 kiloyears before present. In 10 kiloyears they disappeared, and the sea level rise about 120 meters. The Laurentide is about 90 meters, Fennoscandian 30 meters of sea level. So when they disappeared, they don't disappear very smoothly like that, very linearly. No, they disappeared by burst. So we get a lot of evidences that when an ice sheet is melting, it doesn't melt very, very linearly and smoothly, but really by burst, with episode of rapid melting and episode more cool. So this is one line of evidence. Another line of evidence is that most of you know that there is the last million of years, 80% of the time we get 4 ice sheets in the glacial climate, cold climate, and 20% of the time, mostly or less, interglacial, like today, with warmer climate. But what is less known is that during glacial time, the Laurentide ice sheet mostly is unstable, and every 6 to 7 kiloyears, she lost a part of her mass. And so the glacial climate is not only cool, it's also very unstable compared to the interglacial. And so we know that when the Laurentide ice sheet did exist, it was very unstable. So the climate was very unstable. All this is in another context than today, where we only get the Greenland, of course. But, and this is the next slide, as you know, there is, and there was, this is the Larsen Bay ice shelf disappearance in 2002. It is a very large ice sheet, and this ice shelf, and this ice shelf is on the sea. And okay, as you are all physicists here, you perfectly know that when an ice shelf is melting, it doesn't matter because it's already in the sea, so the level is not changing, which is perfectly true. And so when the Larsen B or the Larsen C last year melt, and it is the Larsen C is the size of the Ardèche department in France, so it's a huge piece of ice sheet that disappeared. And when it disappeared, it doesn't change directly the sea level, but in fact what you see here is that because the ice shelf get a bus stressing effect on the ice sheet, when the ice shelves disappeared, the ice sheet lost a part of their mass, and this contribute to the sea level rise. So the ice shelves get an important role to maintain the ice sheets. Okay, for all this reason I was talking about you about, we decided to make an experiment just to explore what could happen if the Greenland ice sheets melt more rapidly, accelerated melting of the Greenland ice sheet. What is the consequences of that? So the next slide explains you the numerical simulation we did. So we get a general circulation model at LSE, which is the IPSL. So here we use it in a certain version, couple ocean and atmosphere. And what we do, so there is, unfortunately, since the beginning of this century, we are stick to the most pessimistic scenario, RCP 8.5. So what we did, we superimposed to this scenario a partial melting of the Greenland ice sheets from 220 to 270, and then we stop. That means that we put a constant fresh water between these two dates, corresponding to 0.5 meter of superimposed Greenland ice sheet, 0.1 meter, 1.5 meters, until 3 meters, knowing that the total melting of the Greenland is corresponding to 7 meters. So we do that, and we look to what will happen. And the next slide show you why do we do that. We do that because we know that in the past, when there is a large surge of melting during Heinrich event, the events during glacial period I told you about, we know by measurement that this leads to a drastic decrease of the ocean circulation and a reorganization of the tropical atmosphere. And this led also to a drastic reduction of the African monsoon. And so this is well known through past data, and this guides us to make these experiments. So here what you see that if you get in this framework a big Atlantic meridional ocean circulation or a small one, it will change on the plot, the 4 plot here. You see that it will change the atmosphere, and especially it will seriously decrease the African monsoon. So we did the same experiment. This is the next slide with also 4 plots, but this time we get the atmosphere ocean model. We just mimic a Greenland melting, a partial Greenland melting, and we look what happened in the for the African monsoon. And what you see here on the 4 plots, the first one, you see that doing that, putting a lot of fresh water in the North Atlantic, will decrease the ocean circulation. But more importantly, on the other plot, you see that it will also decrease the temperature signal and the moisture advection in the Sahel region. And why is it so important? It is because, as you know, Sahel region remains a very demographic area. So North Africa, Morocco, Tunisia, Algeria already get family of 5 children, rather than in Sahel, they of 2 or 3 children, sorry, rather than in Sahel, you get still a large demographic dynamics with big family. So this is a region which is very vulnerable. So on the next slide, you see the precipitation over a box corresponding to the Sahel. So what we did, we make an anomaly between RCP 8.5 and one of the scenario corresponding to a melting of 1.5 meter of the Greenland ice sheet. And what you see on this box, you see in ratio, but it corresponds to anomaly, you see a decrease of the African monsoon during the summer period. And why is it is important? It is because that if you get a decrease of the precipitation over this area, you go beyond the threshold of the culture, which are mainly millets and sorghum in this area. That means that you are increasing surfaces where you cannot cultivate it, and you damp the monsoon, so people will be obliged to leave because of the dryness of this area. So the next slide shows you the same thing for the same box, but this time it shows you that in time. So you can see here the RCP 8.5, what happened when you had 0.5, 1, 1.5, and 3 meters. And you see that each time you decrease drastically over this box the precipitation due to the summer African monsoon. Okay, so why is it so important? And this is the next slide, maybe the most important slide for this part. If you are curious and you want to know what happened in the 21st century in the Sahel region due to the different CO2 pathway, you will see that all the models get a different response. That means that for African monsoon, in the chapter concerning African monsoon and Asian monsoon, you can see in the last report that some models show an increase, a decrease, a change in localization, or not any change in localization. But when you put a lot of iceberg over North Atlantic, which is another thing, then you get a very strong response of the African monsoon. So on the top plot you see the different RCP, but we are here only interested by the red one, which corresponds to the RCP 8.5, and you see that everything is possible when you just increase the CO2, but when you make a surge of iceberg as we did, you get a large variation of the monsoon. And on the right plot, on the right, the figure on the right shows three important things. The A corresponds to the agricultural surface that we lost due to the decrease of African monsoon. The figure B shows you that this is leading to a large migration of population. So the B curves is considering the population as today, whereas the C curves corresponds to accounting for the population dynamics, also including the IPCC as scenarios, and of course it is much more important. Okay, so now I think so. The next the next slide is just to show you what happens and how much the region are impacted when you don't. I don't speak anymore about the superimposed melting of the Greenland. I just show you what happens if we fill the bass by 0.5 meter, by 0.5 meter or 2 meters in different regions. And as you can see here, the most impacted region, of course, is ASEAN. And just the fact that the sea level rise, either from 0.5 meter or for 2 meters, oblige a large part of the population to migrate, directly or indirectly. And the next slide is just to tell you that what we show finally in this example, based on the most pessimistic scenario, but which is the most realistic, unfortunately, is that if you get an accelerated melting of the Greenland, and this is not completely excluded, you will have impacts on the tropical area in regions that are densely populated. That means that you will have a migration of the population as you expect on the coastal area, but also migration of the population in the monsoon area where there is a very high density of population. And just to get a step further, and I will not discuss that here, we do something different. We looked about the human migration, as I told you, but then we also get a collaboration with people working on pathogen vector dispersal in Liverpool to see what will happen about if there is changes in the tropical hydrology that will lead to changes in the malaria region of dispersal region. And this is just that shows you for different scenario. Okay, the 4 main scenarios, so you can just look to the RCP 8.5 here. Just that, what will happen? What will happen concerning the malaria? So here we get several climate model and several pathogen vectors, but the more important thing to know is that when you change the climate with the RCP 8.5, what happens is that in the plain where you actually get a lot of malaria, it's too warm, and in fact the malaria disperses over region in East Africa and South Africa in the island where there were no malaria before, and where now it begins to get a spreading of this illness over new region that were not colonized by this pathogen vector before. So okay, that's it. Now I will go to the third point of my talk. So a lot of things are emerging on the impact. I just show you one example, but there are plenty of examples. I get a lot of friends and colleagues that works on extreme events, well, that you hear every day or every 2 days at the TV or at the radio. But okay, you get a lot of people working on the impact of climate changes. And what happened is that during the COP21, because we made a lot of seminar on climate and explained to the people from the École Supérieure de Journalisme, which is a journalist school in Lille, they come to us and they say, okay, if you believe really what you said, it is fundamental to form the journalist to this climate change and to the different impact of climate change. So this took place maybe 3 or 4 years ago. So with colleagues from the IPSL and LSA, we think about it, and we built an online French language master that deals with all the impact, or mostly all the impact of climate change. So this slide show you the aim of that. The aim of that is to allow to journalists that are communicators that wants to know a little bit more about climate to be formed. And why for me it is really important, it's just because what the people from the ESG, the High School of Journalists, told me is that in the next decades a lot of problem will occur. The more the journalists will be formed, the more they can have some ideas, some tracks about climate, their knowledge increase about climate, the most it will be powerful and efficient to communicate. So we decide to do that, and the next slide show you a little bit what we did. And so there is each time one expert and one journalist, so that the expert doesn't go on bad tracks, that the journalist always tell him. So it's a kind of co-construction. For instance, for climate, I work with Sylvestre Huet, who is quite well known on climate for journalists. There is also things about biology, society, economy, and energy. Also, I don't know how you thought that, justice. I mean, the climate justice, the problem with the laws when climate is changing, and even there is something about philosophy and philosophical concept change due to climate change. All this is to explain you a little bit how the next idea has come to me. So this is the end of the first part, which is how I came to think about what we can do concerning energy. So because next slide is because I'm a paleoclimate, I get this idea that anyway, what we are doing as an experience, which is the Anthropocene, will not last long. I work on period of million of years for deep time climate modeling. So anyway, what is sure is that if we burn all the fossil fuels, if we do that, it will not last long, some centuries. So for the Earth's history, it's nothing. Then the climate will re-equilibrate. So this kind of fireworks that we are producing is okay, it's very important for us. But for the Earth's history, it's just nothing. But it's very important for us. Why? But one of the reasons, but there are many reasons. One of the reasons is the bottom plot here, is that we are doing this experiment in a very peculiar climate. Maybe most of you think that most of the time on the Earth there are ice sheets, but in fact it's completely wrong. Most of the time on the Earth there are no ice sheets. Only 10% of the history of the Earth you get ice sheet as far as we can know. So it's really something peculiar. So we get, moreover, in this period we get two ice sheets. One in the north hemisphere, one in the south, which is completely infrequent for the Earth's history because we are in a period where the CO2 is low compared to Earth's history. So we get these big ice sheets sitting on the northern hemisphere and southern hemisphere, and they can melt. And what is the problem? The problem is the next slide, is that I told you at the beginning that, okay, it was a problem of some centuries, the Anthropocene, but okay, during these centuries, we will be 9 billion of people, and many people live near the seaside, so it is really a problem. And so the next step is, and the next slide is a shift to energy. And so, and this is maybe an important slide, is that to this point, if you really want to do something of your scientific life and you are a climatologist, person, modeler, or paleoclimate, it doesn't. You can ask you, what can I do to help and to be useful? Is it possible that all what we did on the climate at the end is a problem of energy, of mixed energy? And so I discussed with some people in the room to know if it is possible to think that we can maybe explain more what are the energetic pathway. Why? The reason for that is that my feeling, and I think it is largely shared in the audience, is that ignorance on energy, in a context where we will have to take very important decisions, ignorance of the population, because the population, and in France is sometimes better than in other countries, but they hear everything. I mean, there are a lot of completely orthogonal position on this energy changes. So I think it's this ignorance implies doubts, and I write it here. Maybe some of you read this very interesting book of Naomi Oreskes that say that in the tobacco and also, I knew that for amiante, c'est pas amiante, j'ai oublié. Okay, and for asbestos, because of the doubts in the population, the companies they can sell their product for 30 years because there were doubts, and the doubts doesn't help to take the action. So for energy, it could be the same. We can last 30 years, but 30 years for the climate, it's very important. So I think I'm quite convinced that it is also very important to increase the knowledge and to have a kind of consensus discussion and to get scenarios for energy, different scenarios, and to explain to people what scenarios, what choice, and this is for me very important. So I discussed with my former professor, which was Bernard Tamin, and who is very involved in this question, and he gave me some slides that I will share with you. So what we are interested, and on this slide I'm not an expert, so you can criticize me on the choice of the slide and everything. But what are the things we are interested in? We are interested to clarify the energy demand, the electricity demand, and we are also very interested to explain what are the constraints. So I put only 3 major constraints for me, but maybe it's not really the most relevant. But there is the first constraint, which is greenhouse gases and energetic pathway. Of course, they are strong link. The second one is the fact that the resources are limited, and the third one is intermittency for the renewable energy. So this is 3 important constraints for me. And the next slide is just a kind of analog to the first slide I show you to the IPCC. It's just to say where we are, what we are doing. We are burning the fossil fuels, and you can see on this graph that this is what we are doing. We are still doing that, and the part of the fossil fuel remained very important today. So this is the evolution in terms of time. And the next slide is also the fact, for me it's quite important, that if you look now on the Earth, the spatial resolution, you see that there is really large inequality on the way we consume this energy. And this inequality is, for me, a strong drag, a severe limitation for energy policy. So this is from the space. And then as for climate, you can think about evolution. And so this is from the international agencies for energy, so you can criticize this. It's just to give an idea. This is an idea of the evolution in the next 50 years. So it's just an example, but it's just to say that if you imagine one pathway could be that we need the double of energy that we are consuming today in 50 years or 40 years, because mainly of the development of countries and the demography. And then you can ask you exactly as for climate, what can we do and what is the state of the art? And this is the next slide that shows you the state of the art concerning renewable and not renewable, or concerning the different energy we can use. And this show you the world, the Europe and France. And of course France is a little bit peculiar, but I think we have to think it globally. So that means the world energy here is where we start from. So the next slide, I think this slide is, I took it from Jean-Marc, and it is to show that we get that, and we also know the tempo of the resource. And this is, for me, a very pedagogic table and slide from Jean-Marc Jancovici that show that the tempo is very hard. This is why we have not to spend too much time. We have to increase the knowledge of people about that. So as he showed here, after 1 century, we will only have nuclear and carbon and coal as possible non-fossil fuels, and many other as renewable, of course. But this is a very short time period to deal with. Okay, and the next one is also from Jean-Marc, and it's the intricate link between climate and energy, and how the energy contribute to the CO2. It is a really very important correlation and linkage that makes the two very important, and this is one reason why I'm talking this evening about that. So you can see here that, of course, the fossil fuel provide a lot of CO2 in the atmosphere, and most of the other one are much more light. Of course, photovoltaic, it's not so negligible because of the construction of the material, but okay, it is really an intricate link, and you can see here the impact of the different sources. Okay, and then just some little ideas. This is just to say that you can also do projection, like for climate, and I'm not an expert, so I just write here what seems to be interesting in this projection. This is the fact that in the next decades, the part of the renewable energy in the increase of electricity will be, I think, in 2040, about 40%, which is very important, which also corresponds to 25% of the net energy. And also that what is important is the fact that indeed in this increase, the renewable energy takes an important role. So the next slide is also from so it's also something I'm not really an expert on, but I think it was interesting to get some figures about the role of renewable, and also about the kind of advice that the International Energy Agency give for the next scenarios, the kind of energy and the speed with which we have to get rid of this energy is still open questions, of course. So okay, I think I tell you everything I want, and the last slide is some open questions. So I didn't take the whole time, so we will have a lot of time to discuss, and I wrote here only some questions that I have in mind, but maybe it is not the good question. So we can discuss of what you want. But I just write here that the first question for me is that we get a lot of data from the International Agency of Energy, but also, as Celine shows this morning, a lot of data and a lot of things are done inside the IPCC in the working group 3 of the IPCC. So from that, I think we get a lot of material. So this morning, something I think Susan asked if it was where we had to do that, which is a good place. My feeling is that from my own expertise and experience, it would be very good if we can have a place where internationally the expert of these questions can also emerge some scenarios. And this is very important, not only for the policymakers, but also to increase the knowledge and to fight against ignorance. And the ignorance is the best motor for inaction. So this is what's important for me. And then, because of the Sandra talk this morning, I wrote also this possible discussion about tipping point in the transfer from one energy framework to another one, and energetic transition, and also what is maybe the most important for me is to increase the level of knowledge and to fight against ignorance. So it's about education on the choices of energy for the 21st century. Thank you very much.
Okay. Thank you. We can take a few comments. It's not only questions, it's comments, and we'll see how to organize the discussion then. This and then Sebastian. Yes?
Stefan Wieland, physicist. If I remember correctly, ice ages, for instance, are triggered.
Can you wait till you have the
microphone?
Sorry.
Stefan Wieland, physicist, CA Saclay. If I remember correctly, ice ages are triggered via stochastic resonance through the precession of the Earth axis, and also maybe also through the change of the eccentricity of the Earth orbit around the Sun. Now, this would be a climate change triggered by astronomical boundary conditions. In climate modeling, do you take into account those kind of factors, or are those negligible?
Well, you're right. As a paleoclimate modelers, I am, and also Didier, who is in the room, we are very interested to test our model with different forcing. So the anthropogenic forcing is a CO2 forcing, as you know. But to show that our model are able to reproduce the interglacial glacier, of course, we do exactly what you say. We change the orbital forcing, which is something that we can compute. And Jacques Lascar, for instance, he computes this variation of precision, or eccentricity and obliquity till maybe 40 million of units. So we know exactly that. So we can force our model with exactly this forcing, and to understand how we get from a glacial to an interglacial, or from the interglacial to the glacial. So this is, of course, very important to test the sensitivity of our model, and this is something we do, of course.
Thank you.
Well, just one thing, because you give me the possibility to say. Thanks to the ice coring, we also know that during this big climate change, corresponding to glacial, interglacial, the CO2 remain in the very narrow window. In glacial times, CO2 is 180 ppm, and in interglacial times, it is 280 ppm. And now we are 410. So you can ask yourself, okay, we are sure that the last 800 kiloyears, because we get bubbles, so we know that the CO2 remains in this narrow window. But when in the Earth's history we get 410. So if you look, you get this value about 3 million years ago during a period called Pliocene. Okay, good. And what did we get during that period, which is quite near 3 million years ago? From a tectonic point of view, it's nothing. We get a 15 meters sea level rise. No Greenland, no West Antarctica, and the thermic dilatation of the ocean, it makes about this. So that means that if we stop everything today, mostly, we just remain to 410, at long term, this is the Greenland will equilibrate, but it's long, with this radiating forcing, and will melt. So this is something that will take time, because the cryosphere's time response is long, but Greenland is not an ice sheet that is able to maintain with very high CO2. Greenland come only 2.7 million of years ago with a CO2 which was already low.
First of all, I would like to thank you very, very much for this remarkable talk. Now, I have a question about a little detail which is important too, I think. You quickly mentioned the melting of permafrost, and you said that the next report by the IPCC is going to take that into account.
Better.
But could you tell us a little more, please? How much additional warming, for example, do you expect from the melting of the permafrost compared to the RCP 8.5, for example?
So, for those that c'est pas grave, faut m'entendre.
I can see that Jacques Trainer is always as good with this machine.
Okay, it will go like that. So yes, it's a good question. I go quite fast. There are important regions that store carbon inside the Earth system. One is the permafrost. It is frozen area. You get a lot of that in Siberia and also in Canada. And this area, if they melt, they will put in the atmosphere a lot of methane. And as you know, methane has a instantaneous greenhouse properties that are about 30 times bigger than CO2. But methane stay on the atmosphere only 10 years, and then it oxides in CO2. So if we melt all the permafrost of this region, and it will be methane and CO2, and it will become something. If we melt all the permafrost, it will be something, I think, about 100 ppm addition from the what we already get when we will melt all the permafrost. Another important storage, which is more difficult to destabilize, luckily, it is a clatrat. Clatrat are enormous reservoirs of methane at 800 meters in the ocean, and this hopefully will be much more difficult to disequilibrate, but it's enormous reservoir compared to the permafrost. So to answer to your question, I think that in the next assessment report, they will better account for the permafrost release during the 21st century, but the order of magnitude is something as 50 to 100 ppm supplementary CO2 due to the melting, with the fact that in fact you also emit methane and CO2. But methane doesn't last long in the atmosphere anyway.
Jacques Charté-Gassler from the Center for Research and Interdisciplinarity. Apparently, for the clathrates and the methane from the permafrost, bacteria are eating the methane and converting it to CO2, and the effect would be apparently negligible compared to our CO2 emissions. But why don't you mention the soils as a source of CO2 emissions? Because it has been proven by multiple studies that soil, when heated, release CO2 in massive quantities. And knowing that the first 30 centimeters of the soil contain as much CO2 as our atmosphere, it would mean that really fast global warming will release a lot of CO2 and have a huge effet de seuil on our atmosphere.
Okay, I will answer to that question with a very, very simple example. Do you know how long the soil existed on Earth? It's very new, in fact. The life on Earth is mainly on the ocean. It is on the ocean from 3.7 billion of years, where the first traces of life existed, to today, and it's only during the Devonian period that you that's really the vegetation developed over continents. That means that before, let's say, 450 million of years, the continents were desertic. Okay, why did I answer that to your question? Because it is a good experience. That means that when the vegetation come during Devonian and colonize the continents were deserted, yellow, and they become to be green. So there is an albedo change, but as you said, the most important is the carbon, because it opens a new carbon sink. Before there were only a new carbon source. Sorry. Before you get only atmosphere and ocean, and suddenly you get a third reservoir. So what happens when you get a third reservoir of carbon with the soil? It decreased drastically the CO2 in the other reservoir, especially in the atmosphere, which is a very rapid reservoir. So during this period of colonization, terrestrialization of Devonian, you can measure it. You get a very important and drastic decrease of CO2. So, of course, as you said, there is important interaction between the soil and the carbon cycle. But what I answer to the previous question is that in the areas that are glaciated and are storing a lot of carbon, if you melt them, you will emit from this area methane and CO2. And okay, this is for sure. And when you said it's negligible versus our pathway, so for instance, we go from 280, at the end of the 21st century, we will maybe double, let's say double, that means more, we will emit more than, we will put in the atmosphere in terms of concentration 200 ppm, and I think that the cumulative effect of melting all the permafrost is at least 50 ppm. So it's not negligible, cumulated all along the 21st century.
Well, I could listen to this for another hour, but I do have one question pertaining to the, well, maybe it's not so important. I was thinking of the snowball Earth episodes in the past, and I wonder if you have something to say about how that happened.
Do you get 1 hour?
Okay.
If you get 1 hour,
Another question.
No. I'm very fan of this period because it is one of the very short events in the geological time scale of the Earth, where there is a deregulation. That means that most of the time on Earth, the temperature is and the hydrology is regulated more or less, and this is why there is life on our Earth since 4 billion of years. But there are periods, very short period of time, where the snowball appears. But this is another seminar we can discuss because it's quite long.
What do you say to people who say that sunspots are causing climate change instead of carbon? There are quite a lot of people out there now.
I think this was a debate some decades ago. I think it's mostly stopped because, unfortunately, the sunspots are just decorrelated with the temperature, actually. So I think, you know, there is a big discussion to know. Some decades ago, for me, but maybe a lot of people in this room disagree with that, but some decades ago, you can discuss about what are we doing now? Are we really doing an anthropogenic experiment with a large increase of CO2 that will warm the Earth, or is it another forcing factors? It's completely not related. But this discussion for me is mostly over because there is no correlation between the sunspots. That doesn't mean that the sunspots do not act absolutely, but all the models, they show that the changes of luminosities with this cycle of the solar, this very small cycle of 11 years, 200 years, it is a very, very weak perturbation. And to amplify that, to get what we have today, it's very difficult. You have to change a lot of things, the cloud properties, a lot of things. So I think it is an interesting, it is always interesting to doubt. So you have to take and to verify and to check. But this reason for the global warming is inappropriate.
From what I've read, people mix in the newspaper, the variation in the number of sunspots with the variation of the irradiance of the sun, which is totally different.
Thank you.
We need to have quick answers.
Thanks for your talk. Just for, I guess, information, Jock, and other people here at the. So this is Kerry King from the University of Texas. We have a journalism workshop as well, where we bring in journalists, about 30 or 40 every. I think we've done it every 2 years now for 3 years, to talk about various energy issues, and we get people across campus just to tell them what's going on, so they can hopefully be a little bit more educated when they talk about energy issues. So I think that's very important. So it's good to hear that that's going on in other aspects of the climate. Your talk here, I think, is trying to help us provoke how we organize ourselves. In some sense, I guess the IPCC organized itself, I guess, before there were a lobby, if you will, of quote unquote climate deniers. Maybe we have sort of the opposite initial condition. We have a large set of existing energy models that are out there and that people trust to a lesser degree, or believe, or don't have any reason not to believe. And we're sort of a group here saying, well, they're actually a little bit wrong, and they need to take a couple of things into account a little bit different. So in some sense, we'd be the deniers to their existing models. So this is maybe an open question in terms of how to approach that. It seems like it's a different starting point. And I'm kind of wondering, how does a group say, you've been running these models, and there's a couple things a little bit wrong about it. You can do a little better. We're here to help.
But I think if you ask the people 40 or 50 years ago, before the IPCC, they wouldn't imagine that such an experiment will take place. I mean that most of the experts, they converge to make some report every 5 years. And I had to say that 99% of the experts in climate agree with this report. So there is a kind of large consensus. That doesn't mean that the report answers all the questions. There are a lot of uncertainties. But the people agree on this uncertainty and agree. And for me, the most dangerous thing is just inaction based on ignorance. This is really tremendously difficult. If people they just have emotional reaction, they do not have the skill to understand what will happen in the next decade, they cannot choose. It will just be impossible. So after that, I think it's a huge effort and a long-term effort to converge to different scenarios, to agree, to make a consensus, will be a very long time. It will take some years, maybe some decades, but I think it is something we can do which will be very useful to show the different scenarios. There is not one scenario, of course, especially concerning energy. There are different scenarios, and people should discuss together, not to fight again themselves to know which pathway the best, but just to try to make a kind of consensus, just to explain people what are the possible choice. Because if people listen to the radio, something and it's contrary, they do no action. So for me, I don't think it's easy. I don't think it's short time debate. I think it's a long way to go, but I think it's a very interesting and exciting way to go, because it is tremendously important for the choice that people will have to make.
Okay, so my question is on your model, and I'm wondering if anthropogenic heat release are taken into account. Are they negligible, and will they be negligible forever?
You mean at long-term scale? Or
Yes.
This is another question. If you really perturb drastically, and this experience, not in terms of CO2, because if you look to the Earth's history, most of the time the Earth experienced very large value of CO2. So it's not the value, it's the speed at which we are increasing it. And also the fact that the starting point is a starting point of climate with a low CO2 and with ice sheet. So the question could be, if we get rid of the West Antarctica and the Greenland ice sheets in the next centuries, will the Earth will come back to glacial, interglacial anyway? Or will it be possible to miss one or two glacial, interglacial? And this is an open question. It is possible, for instance, during Pliocene, the period I told you 3 million years ago, where we get also about 400 ppm of CO2. And at this time period, there were not a big oscillation between glacial and interglacial, as we know, because the CO2 was too high. So that means that The perturbation that we are making, as I said, in terms of perturbation, will anyway doesn't last long because we do not get the fossil fuels to last it for thousands of years. But the impact of the climate change and the irreversibility on the system could be much longer, of course.
Thank you, Klaus Lackner. Thank you for a great talk. Mine is less than a question than a comment. I think your idea that the energy stakeholders in this story have to come together and tell the story from the side of the energy rather than just from the climate change perspective is actually very important. To give you an analogy, if you worry about noise reduction, we can start worrying about cars, and the next thing you tell me, we really shouldn't have any profile on the tire because that's very noisy. And this would have very many other negative effects, but we are starting from the perspective we need to fix the climate change, and that of course is correct. And clearly the biggest player in that story is energy, but energy is also important in its own right. Otherwise, the solution would be we just give up on it. Right? We need the energy for social equity, for development, and so we need to figure out how to do this right. And this is more than just dealing with climate change.
Okay, I agree with that.
Gilles? Okay. So, Susan.
All right. Yeah, we were gonna put together the energy in the climate change here and think about what we might do about the energy and should it be a beefed up part of the IPCC or its own thing. And I would put forward that under no circumstances whatsoever should we do an IPCC type energy scenario thing. If anybody proposes that, just tell them no, we don't have 35 years to model energy scenarios. Are you kidding? I mean, modeling climate, that's science, but energy is other things. It's not a thing that it matters what the scenarios are. It matters what today people in a position to invest in something do. And scenarios do not inform them of that. So that's my 2 cents worth.
Thank you, Susan.
I don't know. I maybe you're right. The point is that the state of the knowledge now is so poor that everything is just possible. So I don't say that we have to do something as analog as the IPCC. I agree with you. It's not. We have no time to build model for 30 years. I totally agree with you. But we have just to think how to increase this level. This is a kind of education problem, not only for stakeholders or policymakers, but also for communicators, for just that this question could be tackled at a certain level. Maybe the idea of scenario is just wrong. Maybe you're right. But I think we should find a place, a structure, and also willing of scientists, because it is, on one way, it is a chance extraordinary that we can do maybe something useful for the 20, 30 years that when we are quite sure that many things will happen. So I agree with you, maybe it's not a good way. I'm not an expert on energy. I don't want to say that. I'm just a climate modeler. But I think, from my expertise, that at least for climate in a time that is not so long, it begins only in 88. So in only 30 years, 40 years, we drastically changed the things. We are able to put scenarios to discuss climate. This is something that is very important now, and I think at a level that is possible to discuss, which is not, I think, the case for energy, but maybe I'm wrong.
Okay, I have like a similar question as Bob had here previously, because I also discuss sometimes with people and they come with objections and I don't know what to say. And one of the objections they come with is that, well, some scientists say that we are approaching a new ice age, and at the same time we have global warming. So maybe these two things will take out each other and we will have no change. So what do you say about that? How shall I answer this? I don't know.
I think, for instance, we get 2 very cold weeks. Myself, I made a lot of paper, and my colleagues, they made a lot of paper on research. It's very rare on paleoclimate. It's very rare that any radio account for that. But when you get 2 weeks very cold, you get a lot of radios that turn to you to go urgently at the radio or the TV to explain why in a warming you get so a cold winter. So this kind of question we will always get them. And each time there is an extreme event, you get, this is the way the communication works. So we have to adapt with that. So concerning your question about glacial occurrences, okay, I think it's an educative purpose. If people understand that what we are doing will transform the environment, and has already transformed the environment in some decades, some less than a century, rather than the glacial interglacial, the present interglacial, for instance, for insulation reason, will last again at least 30 kilo years. So we have time for that.
Nadia, it's Nadia.
I was about to say that. So Nadia Maizi from Mine Paritech. I have a question about this idea of consensual scenario, because I don't understand the idea of consensual. What do you mean? And don't you think there is a huge community of modelers that are working on energy systems and that are proposing these elements that can bring the fact that climate is a big issue and has impacts for stakeholders and for citizens?
Yes, I think exactly what you said. I think that maybe consensus is not a good idea, a good word to use, because, for instance, for the pathways that are driving the climate, there is no consensus. There is just scenarios. There is scenarios. RCP 2.6 is just unrealistic. We know it. RCP 8.5, for all the reasons, is also maybe unrealistic. But it sheds light on a phase space where you can investigate, explore, and discuss. I think for the energy, it is also possible to discuss and to have pathways and to discuss the impact of these pathways. So if you tell me it's already done, okay, it's good for me, no problem. But I don't get this feeling that from a citizen point of view, or even stakeholders or policymakers, it is so clear.
No, but I'm not sure that it's clear for them, the climate issue itself.
I agree, but for climate we make a lot of effort to try to do it. I mean, you know, you can get the best information, the best model, very well validated. Then the problem is how people will listen to you. And this you cannot control. What you can control is the signal that you emitted. The reception of the signal is much more difficult. And so my point here is that is the signal, and not the reception. I'm interested in as a citizen, but I don't think I manage that. Anyway, merci.
Gilles talked about this merchant of doubts, but there is something new, I think, and which is more, which has democratized in a way. It's the production of ignorance, and it even has a name. It's called agnotology, and there are people working on that.
Well, I did want to say something earlier, and this is probably a better time to say it. There is an organization in existence which I think serves the purpose that you were suggesting needs to be served, and it's called the International Agency for Assistance. What is it?
That's a point.
International. IASA. Anyway. Agency, associate, anyway, for systems analysis. It's in Luxembourg, Vienna, outside of Vienna. It's an international group. That's really the point. It was set up in the time of the Cold War. It came to a major change in direction around the time of the end of the Berlin Wall and so on. And it is now largely focused on energy as a major subject. And it has, in the last, I don't know, 5 years ago, came out with a huge report, which apparently not many people here have, but I have it. And, sorry? The global energy. Yes. Yeah. And it's a it was a major study and well worthwhile, and I think as an organization, it sort of fills the bill.
Okay, so yes, this is interesting.
That would be my
So I have the microphone. Sorry. Can I ask? Okay. Thank you very much. My name is Gregor. I don't know if this is very related, my comment, but since it hasn't been mentioned so much today, and since you showed a slide about how much energy different countries use per capita, I just wanted to get back to this problem that the world is actually really unequal. And I think whatever scenario we build, at some point we probably also have to talk about who is shouldering this burden and redistribution. Because among economists, and I'm an economist, there's this story that, we just grow out of this and we can only move towards situations where everybody is better off, but you cannot do something where somebody is suffering, although there are all sorts of compensations, discussions. But I think in reality, what we see is these kind of scenarios require a momentous change in energy mix, the energy production mix, and at the level of countries, we see how difficult this is. Just an example, Germany was pretty fast in introducing solar energy, and how they finance it is basically with the transfer from some people in the country to others. And this transfer is now almost on the order of 1% of GDP, and people are pretty unhappy about it, those who don't have solar panels on their roofs. But, it kind of works within one country, but whenever you raise the question, can we maybe help get some countries on a different trajectory than the ones that are already rich now, this is a politically hot potato and you cannot talk about it. But I think this is a huge problem with any of these very ambitious scenarios, that they aren't really connected to this political issue of redistribution. And I think maybe not today, but we have to talk about this too.
Yeah, I agree. I'm personally convinced that the inequality is a strong and a severe limitation to climate change policy. The most I'm not a researcher in human science, but there are plenty of researchers that show that in fact inequality was a severe limitation to energy policy changes. I agree with that, but I have no solution of that. But yes, of course, we have to know where we come from, and this is why I show this slide. There is a huge difference in the consumption of the planet, a huge difference, yeah, sure. But okay, this is another big problem. But
yes, Yves Brechet. Gilles, I would like to come to your very last point, of which we have said very little, which is the need for education. I think that's an important issue because there is a question of time scale. We have to do things on a short time scale, and education is something which takes a long time scale. So would you elaborate on that? Need for education doesn't mean that we try to educate policymakers, which very often means we try to influence them. Does it mean that we try to educate our fellow citizen, which means that it will take time because you are convinced only by reasons that you find yourselves? How do you combine all these issues, and what would be your viewpoint of this question of education?
Well, in fact, if I give you the feeling that I didn't talk about it, I think for me it's very central to what I said. I think you're right. Education takes time, but education is something that is not irreversible. But if you think about Pasteur, about hygiene, about the fact that you have to take some precaution, now it is in your mind. For me, climate change and is a kind of thing like that. You have to know something about that, and you know what you can do, and if you do something that you know that is really something that will have a large carbon imprint, you know it. After you do what you want, I cannot anyway be a policeman, but people know what they are doing. So I think that what you said, for instance, this morning about the DOE and all this, I think it's very important to do lobbying, of course, to try to convince the policy makers. This is very important, and this is something that is, I think, more or less done. I think it's also important to convince the population that is able, that has the education at least to understand quite fast what we are talking about. And in France, for instance, it's a large number of people. And so I think it's not so long. Of course, you're right. Education in terms of generation will be too long. But the point here is that we have to fight against something that is the worst for me, is emotional reaction. So if people are just driven by emotional, by the fear, by irrational things, it's not very good for the choice of energy. It's good that if they know what they are choosing. So for me, it will be long. Of course, it will be long, but we have a little bit of time. And if there is any effort for education, it is very dangerous, because it means that only some people will be able to decide for you. And if they are not very well advised, or if, it's quite dangerous. So I think anyway, the education, even if we love at the end, will be something good, because people will know a bit more about it. And this, I think, remains very important for me. So when I say education, it's not only lobbying for policymakers, which is absolutely necessary, but it's also increase the level so that people take decision not too much irrational, just because they are afraid. And sometimes there are good reasons to be afraid. That's not my point. My point is to get good skill, or the best skill possible, to take a decision with the less of ignorance possible.
2 points. First, on Thursday afternoon, there'll be several round tables running in parallel. We can have one on this question of education and since there are Clémence and Audrey who are interviewing a number of people about what's going on in their country, we can start with this. We have also a proposition to discuss, and we would like to discuss with anybody who's interested. So we can address this question on Thursday. The second point is that it is 10 o'clock, and
after it's more expensive.
People who need a beer. So, if you're okay, or you had a last remark, okay. Yeah, we can still continue, but.